Thank you. I'm going to take you far out into space today, farther than humans have ever been. In fact, I'm going to take you into the galaxy. What I'd like to talk about is a privately funded effort to see if there is life in the universe and eventually begin to see how the life here can expand in the universe. We're a foundation started about 9 years ago. I'm going to talk a little bit about what we do, but our sponsors are some of the most successful entrepreneurs in the world, including Mark Zuckerberg, the founder of Facebook, Sergey Brin, the co-founder of Google, Yuri Milner, the founder of DST Global, Ann Wojcicki, the founder of 23andMe, and Pony Ma, the founder of Tencent. We started this effort, I guess it's about 9 years ago, and there's two pieces of it, and I'll talk a little bit about both of them. But the thing I want to mostly talk about is what we call the Breaktrough initiatives. These were announced on July 20th, the anniversary of the Apollo moon landing in 2015 at the Royal Society in London. Here you see the founding sponsor, Yuri Milner, and Stephen Hawking, that until his death last year was our senior science advisor. And these initiatives were designed to do three key things. The first one is answer one of the mankind's oldest questions is there any life elsewhere in the universe? And just to remind you, the only place we know there's life is here on Earth. So this is a fundamental question of science. And the second one, maybe even more significant, is there intelligent life elsewhere? Now, unfortunately, I spent a good bit of my life working in Washington, D.C., and so my view of finding intelligent life, even on Earth, was a little low. The closer one gets to national capitals, it's a key question. But this is an interesting one. This is known as the search for extraterrestrial intelligence. And the third one is probably, to my mind, the coolest thing, because ever since I was a little boy, I looked up at the stars and said, can we go there? Can we travel between the stars? Now, just as kind of a background again on our foundation, the foundation gives the world's largest prizes in science. There are 4 $3 million prizes for life sciences, 1 for physics and 1 for mathematics. These were started in 2011. These are some 2.5 times larger than a Swedish prize I'm not supposed to mention. But how I got involved, I used to run one of NASA's centers, the NASA Ames Research Center in Silicon Valley, and Vanity Fair, who does the Oscar party, the post-Oscar party, asked if they could do their ceremony there. And I first thought they wanted to see if I had the nicest clothes of any NASA center director. My assistant said, no, you're near the bottom. But at any rate, I got invited to these ceremonies because I was a landlord. But one of the things I just want to point out to you that last year we gave a special prize in physics to this distinguished scientist here. This is Jocelyn Bell Burnell, a British astronomer. For those of you that know the history of astronomy, she was the actual person that discovered pulsars, which are stars that maybe the mass of the sun that have collapsed down to something the size of Sophia and spin very fast. Indeed, her advisors said, oh, that's rubbish, don't look at it. She did look at it and proved this is one of the most interesting phenomena in astronomy. But they gave the Nobel Prize to her advisors, not to her. This was an injustice, and we corrected that last year and gave her the special prize in physics. But even more interesting, Jocelyn decided rather than to take the $3 million, she donated it to form fellowships for underserved students and women, which I think is really cool. Now let me talk about Breaktrough Starshot. This is maybe the most, kind of far out thing that we're doing. What our primary objective here is to see if we can travel between the stars. Now, we looked at this a few years ago, and we'd like to go to the nearest star system, and maybe a few of the other ones. That star system, I'm going to talk a little bit more about it, is Alpha Centauri. It's only 4.3 light years away. It takes light 4.3 years to get there or get back. And it's only 300,000 times further away than the sun, so maybe it's possible. We would like to send a probe there sometime by the middle of the century, and then send data back. Hopefully we'll find a planet in that star system that may be life-bearing and maybe even had evidence for intelligence. We'd like to launch this within 30 years at an affordable cost, and we think affordable is about what big science projects cost, like the Large Hadron Collider in Switzerland. But to do this, we have to go, and I'll put this very technically, fast. We need to go 20% the speed of light, which is 1,000 times faster than we can go today. So quite a big challenge. Fortunately, we're finding a couple trends that you're going to hear a little bit more about from some of the other space people who are going to talk, is to lower the size of the spacecraft to really tiny, and I'll show you how tiny in a second. Second, we want to not have a rocket engine. We want to leave the propulsion on Earth, and we use a very old idea. We'll take our spacecraft and attach a sail to it. It's actually a light sail, not a wind sail, that's maybe 5 or 10 meters across, and then we'll push that, but not with wind, but with light from an incredibly powerful laser. When I say powerful, I mean powerful. This is a laser that's kilometers across that puts out 100 gigawatts of power. Now, when we started this didn't look very feasible, but spacecraft are getting really small. I brought one with me, and you can probably see the little piece of plastic. Inside that is an electronic chip. That is a complete spacecraft. We call it a starship, or chip. And this is what we're going to send to the stars. So this is a pretty cool technology, and it's actually coming today, and there are a number of people working on it. Well, now the next question is there any place to go? And, when I went to graduate school in astronomy way last century, like in the 1970s, most of you probably weren't alive then, we were told that maybe 1 out of 10,000 stars in the galaxy, of which there are about 10 billion, had a solar system like ours, and maybe even 1 in 100 of those had something the size of the Earth. But we now know that essentially every star in the galaxy has a planetary system like the sun's solar system. So I want to talk a little bit about the nearest star system. This is our target. This is the Alpha Centauri system. And it's an interesting system. It has 3 suns in it. 2 of them are kind of the size of our sun. One's a little bigger, one's a little smaller. And as I'll talk about, astronomers aren't very creative in naming them. They named one of them Alpha Centauri A and the other one Alpha Centauri B. And then there's a 3rd star in that system, which is called Proxima Centauri, and it's what's called a red dwarf star. And it's a star that's maybe 10% the mass of the sun, but only puts out maybe a 10,000th the light of the sun. And so these stars orbit around each other. Indeed, there was a Chinese science fiction series the last few years called The Three-Body Problem. It's good science fiction, but bad science, that talked about this system. And this system is only visible in the southern hemisphere. If you go south of the equator, it's the 2nd brightest star in the sky, so it kind of is a beacon to those of us that live in the southern hemisphere. Now, this is the Very Large Telescope in Chile. And again, I'll talk about titles. I mean, I think you could think of a better title than Very Large Telescope. These are 4 8-meter telescopes. We have an instrument right now, right tonight, on that telescope that will be the first time we might be able to directly see a planet that's the size of the Earth orbiting one of those. Now, I have to have a little digression here, again, about astronomers naming things, and I am one, so I'm ashamed about it. There's a new telescope they're building, and guess what it's called? It's the Extremely Large Telescope. It goes from 8 meters to like 39 meters. And now, this is really true, that initially when they planned on this, and this is the European Southern Observatory in Munich that did this, it was going to be called the Overwhelmingly Large Telescope. But they had a budget cut, so it's now just the Extremely Large. So we can still build an overwhelmingly large telescope. But with that telescope, we'll be finished in about 6 or 8 years. We'll be able to not only see these planets around the nearest stars, but get data that can tell us if they have life. Now, I want to talk a little bit, and kind of in the last few minutes, about a really speculative concept. And this is the question of where did life come from on Earth? Now, most scientists would say, well, it evolved here, maybe in some pond of stuff on the Earth, or maybe at the bottom of the ocean. But there are a few scientists that say it actually, life may have come from elsewhere. And this is called panspermia. We have a major conference. We just finished this conference a few weeks ago. It was at the University of California at Berkeley, that asked questions that could life on Earth come from somewhere else? And maybe, and I'll talk a little more about this, maybe it was an intelligent alien entity that planted life on Earth. And then the last one is, well, if intelligent entity could put life here, can we put life elsewhere, and should we? This was originally thought to be kind of silly, that, well, stuff can't travel between stars. However, just last year, for the first time, the astronomers found an object that came from outside our solar system. It came from another star system. It was discovered with a telescope in Hawaii, and it was named a Hawaiian name, Oumuamua, which stands for distant wanderer. And this is kind of a neat object. And as I said, it came from outside the solar system. But there's something strange about it. As it was leaving the solar system, it started to accelerate slightly. Now, sometimes things do that. Usually there's ice and things that are evaporating will push it. In this case, we saw no ice. So in fact, the chairman of our astronomy advisory group for Starshot said, this behaved more like a light sail, like one of those things we're trying to build. Now, I think he's probably wrong, but it's an interesting possibility that aliens may be looking at us, and that's one of our other projects. Now, the reason we talk about the idea that life can be directed between star systems, it's called directed panspermia. This was a concept that was really talked about a lot by Francis Crick, the co-discoverer of DNA. He received that Swedish prize for that piece of work. And one of his chemist colleagues, Leslie Orgel, in the 1970s. And this is one of the most interesting things, the intentional spreading of life between star systems by an intelligent entity. Now, this guy is very famous, George Church. He's a geneticist at Harvard University. And he's, by the way, he's trying to resurrect woolly mammoths and other cool things. During one of our conferences, he suggested, well, we can do this using this technology I just showed you. Now, I kind of really love his picture because he does kind of look as how I imagine God might look. So this is a kind of a godlike discussion. But at any rate, this is a real possibility in this century. And there's a big argument. Should we do this? Is it ethical? What if we don't know that there's life elsewhere? So this is one of the big topics that we hope to discuss over the next few decades, because this is a decision we have to make. Now, I want to close with this picture. This is an astronomical artist picture. And by the way, I think artists are really cool, and these pictures are probably a lot neater than things really look. But a few months after we announced Project Starshot, the European Southern Observatory announced they found evidence for a planet orbiting the third star, Proxima Centauri, that's the size of the Earth in an orbit where the climate could be the same. And this is what an artist thinks that planet might look like. So what's really interesting now is we've actually are pretty sure there's a planet the size of the Earth that has at least the temperature that's appropriate for life as we know it. So I'd really like to close with just a thought here. In the last century, humans, us, became an interplanetary species. We're on the verge of settling the moon and Mars. We've been to every place a lot of places in the solar system. This century, the century that you as entrepreneurs and innovators are making happen, will be the century that we become a galactic species, that we move out in the galaxy. So Godspeed to all of you, and thank you.